Hello and welcome to today's class on understanding geography with diagrams. Let us start the analysis. See, today we'll be studying about your gyre circulation. Gyre is nothing but the circular movement or the circular motion that is formed by the oceanic current. Now, within this diagram, you can see that there are five prominent gyre. The first gyre is nothing but your North Atlantic gyre, second is your South Atlantic gyre, the North Pacific gyre, the South Pacific gyre, last but not the least is your Indian Ocean gyre. We'll discuss one by one about each and every gyres. But now, first of all, understand that see each and every gyre is originated because of one and only one thing is your equatorial current. Remember that the earth rotates from west to east, and as you can see this equatorial current are none other than they are moving in the direction from east to west, that is opposite in the direction of the rotation of earth. It is the earth's rotation that is responsible for the formation of this equatorial current, and this equatorial current helps in the formation of the other currents. We'll study one by one. Let's start with the this your gyre, that is your South Atlantic gyre. Now within the South Atlantic gyre, first of all I want you to look into the North Equatorial current and the South Equatorial current. Now this North Equatorial current originates because of the upwelling of the cold water mass. This is your Benguela current, this is your cold water mass that is upwelling, and this upwelling results in your formation of your North Equatorial current. This North Equatorial current helps in development of the Gulf Stream. This Gulf Stream further develops your North Atlantic drift. Similarly, we have the South Equatorial current. Again, the South Equatorial current is nothing but your continuation of your Benguela current. And within this thing, you can see here is a unique current. This unique current is nothing but your counter equatorial current. How is this counter equatorial current formed? See, whenever this equatorial current basically they clash over here or they collide with the coast, there is an they move there is an opposite direction of the current that moves, and this is nothing but your counter equatorial current. Next, within this South Atlantic Ocean, or you can see that first of all it is the South Equatorial current that leads to the development of your Brazilian current. This Brazilian current is nothing but your warm current. As you can see, the warm current has been color coded with yellow and cold current has been color coded with blue. And this Brazilian current again it moves towards the south and it gives rise to the west windward drift. What is this west wind drift? This west wind drift is nothing but your extensive cold current moving from west to east without any blockage. The west basically what happens is that the west wind drift is extensive because in the southern ocean there is hardly any land barrier, and whenever there is a land barrier like you can see over here, this west windward drift, it what happens that when it faces a land barrier then a counter current flows over here, and this current is nothing other than your Benguela current. As it has been written, it originates when the west windward drift obstructs the southern tip of the African continent. I hope this diagram is clear. Next, let's look into this is your North Atlantic Ocean. Now within this North Atlantic Ocean, basically we have the North Equatorial current. This North Equatorial current is giving rise to your Gulf Stream. But look at this, the North Equatorial current, one stream is moving over here and another is moving over here into the Florida. This is called your Florida current. Again from the Florida current there is a Gulf Stream. Now why is it called a Gulf Stream? Because it originates from your Gulf of Mexico. The Gulf Stream when comes in contact with your when comes in contact with your westerlies results in the North Atlantic drift. So basically what you can see from the North Atlantic drift is that here the eastern part of the continent in the lower latitude has a warm current, whereas in the higher latitude what happens is that it is the western part of the continent that is having a warm current. This North Atlantic drift results in the formation of a European type of climate, or we classify it as the CF type of the climate. It means 130 centimeter of rainfall distributed well throughout the year. If you do not know what is the CF type of the climate, I would request you to watch my video on the Köppen's climatic classification. Next, again, as you can see, the Gulf Stream has two. The Gulf Stream is divided in two parts. It's your North Atlantic drift and it's your West Wind drift. Again, this West Wind drift, when it clashes over here in the Western European coast, results in the formation of the cold Canary current. The cold Canary current is nothing but the extension of your North Atlantic drift. Again, remember that North Atlantic drift is warm current, which is resulting in the formation of your Canary current, which is your cold current. The Canary current, what it does is that it brings respite in the Western African coast by reducing the temperature and humidity. Next, within this entire gyre we have your Saragossa Sea. What is the Saragossa Sea? The Saragossa Sea is the sea which is a boundaryless sea. Means it has no boundary. This boundary is completely constituted by the currents: North Atlantic drift, Canary current, and your Equatorial current. This Saragossa Sea is classified with the high pressure. That is, a high pressure prevails over here. As a result of this, what happens that this region is completely calm, and hence there is prevention of the mixture of water. It means that this complete area there is no mixture of water. With the absence of mixture of water, this Saragossa Sea is classified with high level of salinity. It is highly saline river or the saline sea. Now let's study about the Saragossa Sea. The Saragossa Sea is derived from the word sargassum, means seaweeds. Prevalence of the anticyclonic circulation. What is anticyclonic circulation? It is nothing but a high pressure zone. The extent of the sea is demarcated by the extent of the seaweeds and the gyral of the ocean current. Remember that it is called Saragossa Sea because of the sargassum seaweed. I have written it over here. It is because of your sargassum seaweed. What are the characteristics? First of all, it remains motionless as the water is surrounded by current from all the three sides, which prevents the mixing of water. Hence, high salinity, that is 37 parts per thousand. Again, it is located in the transition zone between the trade wind and the westerlies. Hence, is characterized by the subsidence of air resulting in your anticyclonic condition. Hence, feeble and calm wind, hence little mixing of water, hence high salinity. Again, with this you basically got an idea of the with the North Atlantic Ocean current and the Southern Atlantic Ocean current. Let's move on to your Pacific Ocean. But prior to we move on, now I hope you remember that I had talked that how the Newfound Island is subjected to fog. The fog is because of the Gulf Stream, which combines over here with the Labrador current. I have explained this in the first part or the second part. Please check into it. Again, as you can see, this Gulf Stream also results in the increase in the temperature of the eastern coast of the United States. Let's move on to the Pacific Ocean. See, this is your entire Pacific Ocean. Again, we have the Pacific Ocean, we have the North Equatorial current. As you can see, North Equatorial current is nothing but the extension of your Californian current. Again, in the part 1 itself, I had talked about the California current. Again, you can see a counter equatorial current. Why? Because of the piling of the water and counter flow. Again, see, within this you can see is that we have the extensive North Equatorial current that is giving rise to your Kuroshio current. Again, you can see there is a cold current, that is the Kuril current or the Oyasho current, that is connected that clashes over here with the Kuroshio current. And remember that this zone is famous for fog, and again this zone is famous for fish. Wherever there is a cold current merging with the warm current, these are the best region for the fishery. Next, let's study. Remember that one thing that you need to know is about the El Nino. What is this El Nino? See, basically over here we have the East Australian current. This East Australian current is nothing but your warm current. And most of the year what happens is that this over here the Peruvian current flows. Now the Peruvian current is none other than your cold current. But what happens is that with the warm current there is convection, hence rainfall. With this rainfall what happens is that the pressure gradient over here is high. Whereas over here what happens when the Peruvian current where it flows, the pressure gradient is less because of the drier region. The pressure gradient is less. When I say pressure gradient is less, means that the level of water is less and the level of water over here is more. Hence a form of a mountain and valley is formed. As a result, water flows from the mountain towards the valley. When this water or the warm water when it reaches over here, what it does is that it replaces the Peruvian current and results in the formation of your El Nino, which flows in a opposite direction. And this El Nino, what it does is that it reverses the wind, means whenever there was a Peruvian current the wind direction was like this, but whenever there is an El Nino the wind direction was like this. So basically from you can see is that with the El Nino, first of all you can imagine that the South American continent, the western coast of the South American continent will receive precipitation. Well, this is a good thing for the South America, but a very bad thing for the Australia, for the Philippines, for the United States and others. Let's see how. See, let's deal with the effect of the El Nino. Now remember that more than 3000 millimeter of rainfall on the Peruvian coast, which is beneficial for the agriculture in South America. Why? Because of the El Nino. Next. However, the El Nino stops upwelling. What is upwelling? Means, see, the cold current when it was over here, what it happened was that it led to the movement of the wind in this direction. As a result, the water was filled from the below by the upwelling. But once this El Nino occupies this region, what happens that this upwelling is cancelled and downwelling is more frequent. Hence, the nutrient loss occurs in this region. As a result, the fish are killed or the fish dies because of the lack of nutrient in this region. Next, again there is heavy rainfall causing flood and landslides where in the Peruvian coast. Again there is a rise in the sea temperature causing the coral bleaching. Again I have taken the class on the coral bleaching. I would request you to go and look into it. Next, effect on the North America. There is a warm winter in the Canada, Alaska and eastern USA because of this El Nino. Again, there is severe encephalitis disease in the eastern USA. This is again another thing. Next, the powerful storms bring 3 times more rainfall in the southwest USA. So basically what we got is that in the United States itself, over here in the Gulf of Mexico region, what happens is that, or in this region, there is powerful storm. Again over here in the Mexico, what happens? There is none other than your drought. Again drought like condition arises over here. Again drought like condition arises over here in Asia. Look at this effect on the other region. Reverses wind, hence prevents the southwest monsoon. Which is the southwest monsoon? The monsoon that arrives in the Indian subcontinent. So this is the effect of your El Nino. Now let's move on to the currents of the North Indian Ocean Basin or the Indian Ocean Basin. Basically we have divided the Indian Ocean Basin into north and the south. Now let's study about it. First of all, see the current in the Northern Indian Basin. The current in the Northern Indian Basin during your southwest monsoon time. Remember that during the month of June what happens is that the wind crosses over here and it results in the formation of your southwest monsoon. This southwest monsoon also helps in the development of your southwest current in the Indian Ocean. See, first of all, what you see over here in the Indian Ocean is that the Indian Ocean northern part is landlocked, unlike the southern part which is not landlocked. Hence, what happens is that we have a permanent gyre in the southern Indian Ocean, but such permanent gyre is missing in your northern Indian Ocean because of the landlocked nature of the northern Indian Ocean. Hence, it is during the southwest monsoon we have the southwest current. Similarly, during the time of the northeast monsoon or during the time of the retreating monsoon, what happens is that the current changes its direction, and it is called as the northeast monsoonal current, which enters into the Red Sea and into the Mediterranean. Now let's move into the, again one thing is that within the southern Indian continent, the southern Indian Ocean, you can see that we have the south equatorial current. This south equatorial current is nothing but the extension of the southern equatorial current from your Pacific Ocean. This southern equatorial current, when it clashes at the Madagascar, leads to your Mozambique current and your Agulhas current. The Mozambique current, Agulhas current combine, and again they result in your west wind drift. Again, the west wind drift is produced by the westerlies. Let's look into over here. Again, there is a continuation of your cold Australian current. Now I want you to look it over here. See, basically what we studied over there is that, see, with the prevalence of your Peruvian current over here, what happens? High pressure, hence here we have desert like condition. Let's look into the condition over here. Again, we have the Canary currents over here. This Canary currents also leads to what? This also leads to the dryness over here, and hence we have a desert like condition. We have the African desert, or we call it the Saharan desert over here. Similarly, over here what we have is that this Canary current again, with respect to now the Canary current, yes, we have the Californian current. This Californian current again leads to desert like condition over here. We have the California, Mojave deserts in the America, which is results of the California current. But remember that despite of the flow of the old Australian current, we do not have desert over here in Australia. Why? It is because of this lee wind current. Again, this lee wind current originates because of the south equatorial current in the Pacific Ocean. As you can see in the diagram itself, look into over here in the diagram. The south equatorial current moves through the Australian coast and over here into the Indian Ocean as your lee wind current. This lee wind current is nothing but your warm current. Despite what happens is that despite of the flow of your Australian current, this lee wind current actually displaces this cold current. Hence, there is almost 1300 millimeter of rainfall in your Western Australian coast. Hence, the Western Australian coast is not a desert. I hope you got the concept. Thank you for today's class. That will be all.